Today, two of the hottest technologies in the solar industry, bifacial modules and solar trackers. My guest today is Bri Bruce, who's the Director of Marketing with RPCS, that's RP Construction Services. And RPCS is a power couple with a company called ATI, Array Technologies Incorporated. And before we get started, I have to, in full disclosure, say that I have a preference for companies from New Mexico, and ATI is an Albuquerque-based company. I grew up in Albuquerque, New Mexico, so it's great to have RPCS and ATI on the show. Welcome to SolarWorks for Illinois, Bri Bruce.
Thank you. Thank you very much for having me.
I discovered a white paper that RPCS published in conjunction with ATI. There's been a couple permutations of it, but there's a May version on your website, and I'll show our listeners a link to that in a little bit, about some of the advantages and disadvantages of different layouts for trackers. The ATI tracker is a one module and portrait design, tried and true. They've been in the market for 30 years. They're one of the oldest racking companies in the solar industry in the United States. They're also one of the top manufacturers globally. So they're a very popular product. We saw trackers come to Illinois starting in 2018. In 2017, when the Illinois industry started to really take off, we were still seeing a lot of fixed ground mount designs. And then in 2018, the ice melted and trackers hit the scene. And now upwards of 90% of the site plans that we see have trackers on the design. And that is because you get more energy by tracking the sun. This is a horizontal, flat torque tube that then rotates east and west, giving the module direct access to the sun's rays, no matter what time of day. And RPCS is a partner of ATI. They have an exclusive partnership, which we're going to explore a little bit. So anyway, this white paper breaks down advantages and disadvantages of one module and portrait versus some newer designs of two modules and portrait that other manufacturers are now making. So Bri, first tell us a little bit about your background and how you came to RPCS.
Yeah, so as you mentioned, I'm the Director of Marketing for RP Construction Services. I've been with the company for just shy of 3 years. Before joining RPCS, I was working in sales and marketing in the tech world in Silicon Valley, and prior to that, spent most of my early career in the publishing industry, specifically in project management and PR and digital media design. So I made the transition to the solar industry, and it came pretty naturally, and it's just been the best career move I could have made. I've not looked back, and I'm very much a solar lifer now. But you know, more than that, I'm just beyond grateful to have found a home with the amazing team at RPCS, and you know, to top it off, we're contributing to the clean energy future as well as driving economic growth and creating jobs. So it's a beautiful thing.
Well, I too have been in the solar industry for just over 3 years. Even though I grew up knowing about solar and doing DIY solar thermal in my backyard in Albuquerque, solar PV wasn't on the scene really until the 2000s is when the solar industry took off, and I was busy doing green building consulting, but it's great to now be in the PV industry. It's one of the fastest growing industries globally, and it's the fastest growing source of new energy in the United States now. It's eclipsed natural gas and coal and is going head to head with wind power. So there's a great opportunity for anybody listening to this who's looking for a new career. Solar is a great career, so check it out. Bri, tell us about the relationship between RPCS and ATI. That's a pretty good story.
Yeah, so RPCS's roots really begin at Array Technologies. Our founder, Eb Russell, used to lead the sales efforts at Array and help them deliver over 2 gigawatts and obtain 85% market share among trackers, starting in 2009. And then in 2015, we extended our partnership with Array to begin offering our signature turnkey design, supply, build service to support developers and EPCs throughout the US. So, you know, we're we're really in a unique position in the market. Not only are we an exclusive partner of Array Technologies, but not many companies have been working with single axis trackers since 2009, and not many companies have seen the life cycles of other SAT companies like we've seen. So to date, we've completed hundreds of projects across 30 states now and counting, and we believe it's our experience that makes us most valuable to our customers. That and just dedicating ourselves to what we know to be the best tracker products for the industry-leading manufacturer with over 30 years under their belt.
So for any of the developers out there or installers who are looking at tracker products, if you want to buy an ATI tracker system that is less than or equal to 50 megawatts, I believe is the threshold, right? You have to go through RPCS. It's an exclusive relationship for the 50 megawatts and down, right?
Yeah, we work on projects anywhere from 2 megawatts sites to 200 megawatts, but really our sweet spot is in the 5 to 20 to 50 megawatts space.
Yep. And I'm going to show the Array Tracker website here in just a second because it is a very unique look. But you mentioned 30 years in the industry. That's one of the key differentiators is they have a very tried and true and reliable product. And it is a unique drive system. Let me just go to that website. They have a cutout of the name Array in the drive fan or the gear fan. And so that's one of the unique aspects of it. So tell us about this white paper. What was the ideation behind the white paper comparing one module in portrait and 2 modules in portrait?
Yeah, so I mean, as we all can guess right now, bifacial modules are a hot topic. And I think that the biggest point of contention when it comes to determining their productivity, aside from driving variables like albedo and geographic location, is what configuration, being 1 module in portrait or 2 module in portrait, is going to yield the highest energy gains. It's relatively new technology, and because of this, it's a little difficult to determine definitively that added energy gain. So this is kind of the biggest unknown, and this is where factors like ground cover and location come in. But what is known is that there's an added gain when using bifacial modules over monofacial modules, and it's an average of 3 to 10%. And Array Technologies conducted some extensive tests in partnership with PV Lighthouse and CFV Labs at their testing facility in Albuquerque, New Mexico. So I set out with a goal to basically summarize these findings in a way that was going to be digestible and highlight the benefits of a 1 module in portrait configuration over 2 MIP. So this white paper functions to provide a deeper look at why 1 MIP on a single axis tracker, specifically the Array Technologies tracker, is going to yield the highest energy gain. And so this 1 MIP versus 2 MIP debate is a little counterintuitive because twice the amount of modules on the racking doesn't necessarily equate to twice the energy gain. The output is really only as good as the configuration. And for this particular white paper, we chose to exclude drivers like ground cover and geographical location, mostly because these factors just couldn't be controlled in the design of the system. And we want to also point out that developers and owners and financiers are always going to be seeking that more attractive bottom line. And so they're looking for what's going to give them greater bankability. And this is something that can be obtained through maximized energy gain. So simply put, if you wanted to maximize gain, maximize ROI of a system, do things like eliminate labor costs and installation complexity or maintenance over the long term, and then also potential destruction during high wind events, you'd install the Array tracker with bifacial modules in 1 MIP.
So I'm sharing the landing page for this white paper on your website, rpcs.com/bifacial module performance. And so if you just Google those words, you'll find this white paper, and you see the image on the left in the red is the two modules in portrait design versus a one module in portrait design to the right. The one on the right is the ATI system. And you can see that they have the same ground cover ratio. So the same amount of the array ground is covered. It's 40% in this case, which is pretty standard for trackers. And it's just kind of an apples and oranges, but there are many subtle differences down the line. And as Bri mentioned, you know, your intuition might tell you that, oh, if we can put two modules up on the torque tube, we're going to get more energy out of the array. But you have to think about with bifacial modules, right? And here's that diagram showing light coming in underneath the array. So bifacial modules are producing electricity from the front and the back side of the module, and you're very keen to get reflected light off the ground or off other equipment onto the backside of the solar panels. And you see here on the top is the one module in portrait compared to on the bottom, the two modules in portrait. The differences are that the two modules in portrait, that array has to be higher up off the ground, and the row distance between the rows has to be greater. And so a net result of that is that you have more losses to the sky. More light is escaping that after it reflects off the ground. And as a result, you get 10% more energy captured by the backside of a single module in portrait. Is that right?
Yes, that's correct.
Wonderful. So let's talk about some of the nitty-gritties that solar developers and installers and long-term owner-operators really need to consider. There's the initial cost of the equipment. There's the constructability and the construction costs. There's the overall reliability and durability, and then the long-term O&M. And so we're going to talk through some of those factors. So out of the gate, those two designs have very similar module counts. But what are some of the differences structurally in a two module in portrait versus a one module in portrait structure?
Yeah, so you know, obviously the biggest difference is going to be what's called the pitch, as you mentioned. That's the distance between the rows. And so when you have 2 MIP, you actually need a greater pitch, a larger pitch between the two rows so as not to create shading. But what you're doing in the 2 MIP configuration is you are raising up that entire system because your center of rotation then shifts. So you've got the two mods stacked on top of one another, and they need more room to track the sun. And because, as you mentioned, you've got an increased spacing, you're losing about 11% to the sky of that reflected solar irradiation. So that's a big point of contention. And you also have to spend more money. There's higher costs associated with 2 MIP because you need a more robust foundation in order to support more material on the racking. So you're looking at, you need longer posts essentially. There's installation complexity associated with building a system higher off the ground. So these are just a couple of different factors that come along with installing a 2 MIP project.
Yeah, I want to talk a little bit about that post length. I'm in the middle of designing and early engineering of a tracker, a 2 megawatt tracker project here in Northern Illinois. And while we do generally have very deep topsoil in Illinois, which lends itself to a driven pile, which is the ideal and very cost-effective system for ground-mounted solar, whether it's fixed or tracker. Raising the array up does mean that your piles get very long. For for a standard tracker, okay, the one module in portrait, we're looking generally at pile lengths of 12 feet, plus or minus a foot or two. As you raise the array up, you mentioned you have to also make the pile beefier because it's a bigger structure and it's got more surface area that is exposed to the wind. So it's undergoing more shear force from the wind. And so you have to have longer piles. And that can lead to geotechnical complications. Geotech is always a great unknown, right? Because you can't see what's underneath the ground. And so you're always on a little bit of pins and needles until you get that report to show you what kind of a foundation system you can do. So what are some of the other differences between the 1 and 2 modules in portrait designs?
Yeah, so I mean, our perspective is that really you'd be doing your project a disservice with 2MIP, you know, in a threefold way. It's cost perspective, from an installation perspective, and also from a production standpoint. So there are a lot of structural limitations with 2MIP. There's going to be the labor costs and complexity, more metal to support more material on the racking. Like we mentioned, it's gonna require longer piles that you need to drive to support a system that's higher off the ground. Because essentially, you know, and then what that's going to cause is you'll have a higher number of failure points. And then, you know, you're creating a bigger sail for wind events. So you're going to have a higher probability in the event, or a higher probability of failure in the event of, you know, extreme weather or wind. And you'll hear some proponents of 2MIP talk specifically about the center torque tube and of the array system and how that shades the module. And yeah, those are great photos right there to show just kind of the what it looks like when 2MIP fails during a high wind event. So I don't think any project owner or developer wants to see that. So you're creating a bigger sail there. And then what you'll see from fans of 2MIP is that, you know, they'll bring up the shading that the center torque tube causes on the backside of a bifacial module. And tests were conclusive in determining that this was very nominal in the tune of 0.02% of a loss. And, you know, just to even mitigate this small issue, Arrays developed a special high-rise clamp that brings the module actually farther off the center torque tube to allow for more reflected solar irradiation to hit the module's backside. But again, this clamp isn't necessary to mounting bifacial modules. The standard clamp is actually also compatible.
Does any of this calculus change if you use a monofacial module, a traditional solar module, in the 1 versus 2? Is there a different outcome?
Well, the bifacial module and monofacial module prices are, you know, they're comparable. And I would surmise that as technology improves and becomes more efficient, then any difference in price is going to be a wash. And so the array system by default deploys a 1 module and portrait configuration. And so this is the basis of their industry success. So you're starting baseline with the same reliability while also adding that 3 to 10% energy boost and going with a bifacial module. So the installation of bifacial modules would be no different than the installation of monofacial modules. And you know, you're still getting the same quality and product, and you're getting the reliability that the array system boasts.
Yeah, it's been interesting to see bifacials coming on. I mean, it depends on which manufacturer you talk to. Some of them got in the game early and then got out, and now a lot of them are getting back into it. But module wattages are climbing fast. It has been interesting just the last 3 years. You know, 3 years ago, we would have been installing 320s to 340 watt modules, and 360 was a big module. Now we don't bat an eye at a 400 watt module, and 500 watt modules, and even 550 watt modules, and even 600 watt modules are on the drawing board and coming. And some of them are monofacial, some of them are bifacial. Of course, the physical footprint of these larger wattage modules is getting slightly bigger as they get bigger, as the wattages get bigger. I'm guessing they're going to reach a peak at maybe 4 feet by 8 feet, the size of a sheet of plywood, just because that's such a standard size in the construction industry. It's not practical to get much bigger than that. But anyway, so single-sided or double-sided module, yeah, there are some people that believe there are some unique advantages. It is producing energy from both sides of the module. So if you've got high albedo, high reflective surface, like a white roof or a sandy ground, so the desert, for example, lends itself very well to bifacial. Here in Illinois, we have dark soil and a lot of ground cover with, grasses and forbs, and I don't know how that's going to play out. It's TBD. We have not installed any bifacials here in Illinois yet, but I look forward to that day. We always like to see the evolution of technology. So the constructability of these two different systems is quite different because of the torque tube height. In a standard single module and portrait, you're looking at about 5 to 6 feet, right? So it's head high. And if you go to a 2 modules in portrait, you are jacking up the array to at least 2+ meters, right?
Yeah, 2 to 3.
Approaching 3 meters. And so what you then have to do is tip the array, install one side, and then tip it the other way, and then install the other side. So it's a little more involved. There's longer pieces of racking involved. And so it is kind of apples and oranges, but certainly my gut tells me from a constructability, I would lean towards the 1 module in portrait. Although I have to say, when I saw Nextracker's 2 module in portrait design, I intuitively wanted it, just because it was different, right? And I love new. It was the shiny new object. But after looking at this white paper and talking to you and learning more about the pros and cons, I have reservations. The long-term durability of a single versus a double, and ATI uses an expression, wind-free, or what is the expression that you use around wind?
Like a failure-free wind design. So they've got a built-in wind mitigation system with the tracker.
Let's talk a little more about that, because wind is a big deal here in the Midwest. Obviously, we have high winds generally. We have a lot of wind power. I thought I'd work in the wind industry before I worked in the solar industry, because we got wind before we got solar. But what happens to a tracker in a high wind event?
So because the tracker inherently has this built-in wind mitigation system, essentially the bearings that are installed along the torque tube come with mechanical stops. So there's no active wind stow required on an array system, and the system itself will sense this wind event coming, and the wind will essentially push the modules into a position until it hits that mechanical stop, and where the whole system can just kind of sit there and weather out the storm. And you're gonna mostly see this in the front or rear rows, not so much in the center rows, but they will track slightly different depending on the wind loads for that particular row. But it's going to be on an individual basis. And then once the wind event passes, the entire system will self-calibrate back to where it's supposed to be.
You mentioned parts and pieces. How does that play into both the constructability and the long-term durability?
So the array system in and of itself has the fewest number of components out in the market right now for a single axis solar tracker. And as an installer, we believe that that's like the best deployable option. Fewest components mean the fewest failure points. So, it's the whole system has an added level of dependability, reliability. It's an incredibly uniquely architected system. It's very robust. That the wind mitigation system is a huge plus. So you're not going to see wind failures with the array tracker. In fact, they've withstood hurricanes virtually unscathed. So it's designed to do what it's supposed to do with zero scheduled maintenance, over the course of its lifetime. And it's a 30+ year asset. So you're going to see both short and long-term ROI.
I want to just quickly summarize this white paper for our listeners. 1 module in portrait versus 2 modules in portrait. At face value, you might initially think, oh, I can get more energy out of my tracker array, especially with bifacial modules, if I go 2 up. The downside is that then you have to go taller. You are using more steel. You have to go deeper into the ground. And then you're exposing the array to potential wind events. And I'll share that photo again, which is, that didn't work. Which is something that really nobody wants to see.
Especially if that's your investment.
Yes, we're talking millions of dollars of equipment that is at risk in these projects. Well, Bri, that's about all the questions I have. I really appreciate the opportunity to talk about this white paper. I encourage our listeners to check out the white paper on your website. And before we end the interview, do you have anything else that you want to share about RPCS?
Yeah, as I mentioned before, we're in a unique position in the market, having been around since our roots started in 2009, and I can speak a little bit to our relationship with Array. We're essentially like a power couple. So we provide the utility market with a turnkey solution for our customers. That's everything from engineering to supply and safe harbor to mech install and commissioning. So we're entirely self-performant, and so that's to say that we own the contract. We use company-owned equipment. We've got just an amazing crew of direct hires that are completely mobile and can be deployed anywhere in the U.S. So we're not just a preferred installer. Occasionally we'll use a sub if it makes sense schedule-wise, or when we're incredibly busy. But as an installer, the array tracker system is incredibly robust. We love installing it. That's our focus. And hats off to Array for consistently innovating. They've most recently created a more universal center structure to make the installs faster, which we love. And we've developed, or rather, Array has developed module clamps to accommodate thin film modules. And as I mentioned, their high-rise clamp is also, another innovation to add to their suite. And over the years, RPCS is becoming better and better at what we do. We're able to take on more projects and bigger projects, all while furthering our expertise and our very narrow laser focus at installing array trackers. And we've made it our mission to build the best, and our own values in quality and service mirror those at Array. It mirrors Array's product reputation and quality and reliability. And we're just very, very glad to be in the space we're in.
I forgot to mention that, besides being an Albuquerque company, ATI, the thing that gives ATI real credibility for us here in Illinois is that about 80% of the site plans that we see specify ATI. It is or has been a 2-horse race between Nextracker and ATI. Those are the 2 largest tracker manufacturers globally. now there's some third and fourth horses coming into the market because both ATI and Nextracker are extremely busy. So their success is to some extent a potential challenge, like any company that's growing very fast. But yeah, 80%, I would say, market share, and that speaks volumes. So congratulations for finding RPCS and a great partner in ATI. I do want to make a couple of announcements. We have our pre-registered events coming up in June. We have Brian Haug, who's the president of Continental Energy Solutions, coming on the show to talk about how the solar market has evolved from 2017 to 2020. And then in July, we have Steve Johnson and John Kivlin from Convergence Energy, who are good partners of ours. They are a solar and storage developer that works throughout the Midwest, and we're going to be talking about their experience doing solar and storage. So looking forward to that. And then I want to encourage all of our listeners to check out our YouTube channel. Please give us a thumbs up. Please subscribe to the channel and share it with your friends if you like the content here. I'm Tim Montague, your host, and I really appreciate everybody's comments and ideas. If you have ideas for future guests to come on the show, we are trying to get more manufacturers, racking, inverters, modules, you name it. So if you are in a relationship with somebody at a manufacturer that you think is worthy of more press, please send them my way. And I want to thank you, Bri Bruce, for coming on the show. It's been great to get to know you a little bit. And I would encourage our listeners to check out Bri's work on Baja. She's passionate for Baja, California, which is a place where I have many fond memories from. When I was in college, I lived in San Diego and did some trips there. So thank you so much, Bri.
Thank you so much, Jim.
Have a great day, and thank you, everybody.